Hello students, good morning. In NCERT Solutions, Maths Class 11th, so we'll discuss today exercise 13.2 and it's related to the differentiation. In previous two classes, I explained you how to calculate the limits and today we'll discuss about the differentiation. So before starting differentiation, you must know the formulas. So in this first few questions are related to differentiation by first principle method. The first principle method is also known as delta method or limit method. So in delta method, one basic formula to differentiate any function fx, we write it as d over dx of fx. What does it mean? It means we are differentiating a function of x with respect to x. You will read it as differentiation of function of x with respect to x. This d over dx is symbol of differentiation. It is a language. We'll use the d over dx is, we'll read it as differentiation with respect to x. So by delta method, if you want to differentiate any function, a formula will be limit. I am writing it as LT s tends to 0 f of x plus h minus fx divided by h. This is the formula for differentiation using first derivative method. D over dx of fx is limit s tends to 0 f of x plus h minus fx divided by h. Suppose you want to calculate derivative at a particular point, any point A, to find derivative at any point A. So what to do? In this expression, you will replace by x by A. In this expression, you will replace x by A, so our formula will be limit s tends to 0 f of A plus h minus fa divided by h, where what is a? Suppose you have to calculate the derivative at x equal to 0, so you put a equal to 0. Suppose you have to calculate derivative at x equal to 1, so replace x by a by 1 in this formula. So that is the formula to calculate derivative of any function using first derivative method or delta method. So in exam, question will be asked and it will be mentioned whether you have to differentiate it directly or you have to differentiate this using the first derivative method. Like question number 1, it is given find the derivative of x square minus 2 at x equal to 10. At x equal to 10. So derivative means we'll write it as f dash 10. Suppose we are calculating derivative in general, that is written as f dash x. In general, f dash x, that would be limit s tends to 0, as I just explained, f of x plus h minus f of x divided by h. This is the formula. Suppose you want to calculate the same derivative at x equal to 10. So what to do? In the same formula, you replace x by 10, so it will become f dash 10 as it is mentioned, f dash 10 is equal to f of 10 plus h. You replace this x by 10 minus f of 10 divided by h. So at a particular point, if you want to get the derivative f dash at any point a, f dash means it is derivative of function, f dash at any point a, f dash a, it would be equal to limit s tends to 0. We'll use this as a formula, f dash a equal to limit s tends to 0 f of a plus h, a is point at which we want to get it, minus fa divided by h. You just learn this formula. In all these questions, only value of a will change. Okay, in some question you have to find, like in this question number 1, you have to find that x equal to 10. So in the formula I have mentioned, you just put x equal to 10, you will get this thing, f dash 10 equal to limit s tends to 0 f 10 plus h minus f 10 divided by h. Now the value of f10 plus h we'll calculate from the given function. How to calculate the value of f10 plus h? For us, the function fx is given x square minus 2. Suppose you want to calculate f10 plus h. In this, both the side you replace x by 10 plus h. So f10 plus h will be 10 plus h whole square minus 2. So I have replaced, you see, it is equal to 10 plus h whole square minus 2. Similarly, to get f10, in the same function you replace x by 10. So it is 10 square minus 2, you can see. So I have replaced the value of f10 plus h and f10. It would be limit h tends to 0, 10 plus h whole square minus 2. In this I have placed x by 10 plus h first and then x by 10 to get these two things. Now you simplify it. A numerator you just open 10 plus h whole square is 10 square plus 2 into 10 into h plus h square minus 2 minus 10 square plus 2. So all the things are cancelled out, like this 10 square is cancelled out by this 10 square, 2 is cancelled out by this 2. In this way, these things are cancelled out. You are left with 20h plus h square upon h. In numerator, you can take h as common and that will cancel out the h of denominator. So you are left with 20 plus h. Put h equal to 0, so its answer will be 20 only. Okay, so now as I explained in earlier question, in next question I will do the same thing. It is you have to find the derivative of 99x, x equal to 100. So first of all you will write the formula. Okay, general formula you can write first of all f dash a, as I mentioned you, a is the point at which you have to find the limit. It is equal to limit h tends to 0 f of a plus h minus fa. First of all mention this formula divided by h. In this you replace a by 100 because we have to find derivative at x equal to 100. So if you will replace a by 100, you will get this as the formula. You see, f dash 100 is limit h tends to 0, f of 100 plus h minus f 100 divided by h. Now you calculate the value of f 100 plus h from this. In this you replace x by 100 plus h, you will get the value of f 100 plus h. Also calculate the value of f 100, also put x equal to 100 in this. So you will get these values. Just open the bracket. In numerator you will have 99 into 100 is cancelled out. In numerator you will have 99h divided by h is cancelled out with h. So answer of this question is 99 only. Okay, we'll move ahead. Now see the question number 3. You have to find the derivative of x at x equal to 1. So again what we'll do, you have to write the formula. So now what is formula? We know that f dash a equal to limit h tends to 0, f of a plus h. Always you will write it as f of a plus h minus fa divided by h. As you have to calculate derivative at x equal to 1, so in this whole formula you replace x by 1, a by 1, a by 1. So we'll replace this a by 1, you will get it is f dash 1. And right side it will become f of 1 plus h minus f1. So see, I have written this formula over here. So now it has become f of 1 plus h minus f1 divided by h. In this step, now we have to find all these values. As fx is given x, fx is given x only. So f of 1 plus h, in this both side you replace x by 1 plus h. So f of 1 plus h will be 1 plus h only. And what will be f of 1? That will be 1 only. So I have mentioned these two terms over here. Now open the bracket, it will be h by h. So we'll cancel out. So 1 is the answer of this question. Find the derivative of the following functions from first principle. Now you have to find the general derivative of all these functions using first principle. So the formula for derivative using first principle is f dash x is limit x tends to h tends to 0, f of x plus h minus f of x divided by h. This is the formula. So x cube minus 27 you have to calculate. So first of all, we have mentioned the formula that f dash x is equal to limit h tends to 0, f of x plus h minus fx divided by h. Now, fx is this much. From this you get the value of f of x plus h. How to get? In this whole expression, you replace x by x plus h. So we will get it is x plus h whole cube minus 27. Similarly, fx, this whole thing is fx. So I have replaced this as x cube minus 27. Just open this formula, x plus h whole cube, that is x cube plus h cube plus 3x square h plus 3xh square. This minus 27 is cancelled out with this plus 27. I have cancelled it out. Okay. Further, next step, this x cube is cancelled out with this x cube. These both two x cubes are cancelled out. So cancel the terms. Now you are left with the h cube plus 3x square h plus 3xh square upon h. And numerator take h as common, and that will cancel out the h of the denominator. So you are left with the h square plus 3x square plus 3xh. In this you put limit h tends to 0. So 3x square would be the answer because this is 0 and this is also equal to 0. So 3x square is the answer of this question. So in this way we can solve this question first part. Now come to the second part. fx is given x minus 1 into x minus 2. So f dash x, always mention this as the formula. F dash x is equal to fx plus h minus fx divided by h. So we'll calculate fx plus h by replacing x by x plus h in this expression. X by x plus h. Alright, actually this is nothing, x square minus 3x plus 2. X square minus 3x plus 2. Alright, so in this you put the value of, it is x plus h minus 1, x plus h minus 2. I have replaced x by h. Minus fx is same thing. Divided by h. Now you multiply these two. You will get this thing and multiply these two. Open this bracket. On opening the bracket, you cancel out the related terms like x square will be cancelled out with this x square. This minus 2x will be cancelled out by this. As similarly, minus x is cancelled out with this and 2 is cancelled out by this. And you are left with the hx plus h square minus 2h minus h. So in numerator you take h as common. That will cancel out the h of the denominator. So you are left with the, in numerator you are left, actually it is 2hx plus h square minus 3h. In numerator take h common, that will cancel out the h of denominator. So you are left with 2x plus h minus 3. H minus 3. In this you put h tends to 0, so 2x is the answer. Come to fx equal to 1 upon x square. So this is the formula for the first principle. F dash x is equal to fx plus h minus fx divided by h. In this I will put fx plus h. As fx is given 1 upon x square, so fx plus h will be 1 upon x plus h whole square. In fx you have to just replace x by x plus h. That's all. Now you take the LCM in numerator, that will be x square into x plus h whole square. So it will become x square. On taking LCM, this x square will go this side. X plus h whole square will go this side. So this is x square minus x plus h whole square. This h I have taken already 1 upon h outside, and this is x square and x plus h whole square is LCM. Now you just open this numerator. So it will be x square minus h square minus 2xh. So this x square is cancelled out by this x square. Now numerator is minus h square minus 2hx. From that you can take h as common. So that h will cancel out the h of denominator. So you are left with minus h minus 2x upon x square plus x into x plus h whole square. Put h equal to 0 now in next term. So you will have, on replacing h equal to 0, so this h will be 0 and this h is also 0. So minus 2x upon x cube would be the answer. That on solving it, you will get it is minus 2 upon x cube. In next question, fx is given x plus 1 upon x minus 1. So in the same formula, f dash x, we are repeating the same formula in all the questions. So till now you can write yourself that f dash x is equal to this much. To get fx plus h, in this you replace x by x plus h. So it will be x plus h plus 1 divided by x plus h minus 1 is fx plus h minus x plus 1 upon x minus 1 in denominator h as it is. This 1 upon h I have taken out, and over here I have taken x plus h minus 1 into x minus 1 as LCM. This x minus 1 will be multiplied with this, so you will get this term, and this is multiplied by this, so we'll get this term. Now in numerator we'll open this bracket, open the bracket. So on opening the bracket, everything is cancelled out. This x square will be cancelled out with this x square, and this x is cancelled out with this x, and like that. You will have only minus 2h divided by this thing. This h is cancelled out with this h. So now you have minus 2 upon x minus 1 into x plus h minus 1. Put h equal to 0. So it will be minus 2 upon x minus 1 whole square is the answer. Come to the question number 5. For the function fx equal to x raised to power 100 upon 100 plus and so on, it is given. Prove that f dash 1 is equal to 100 into f dash 0. So the function fx is equal to this much. Now we will differentiate it by normal ways, normal methods. Now you need not to use the first principle method. So in normal methods, suppose x raised to power n is given. Its derivative will be n into x raised to power n minus 1. One more thing, suppose some constant into x raised to power n is given. Constant means any number or anything independent on x. Okay, so we can take this k outside and differentiate x raised to power n. And differentiation of this x raised to power n will be n into x raised to power n minus 1. So in this question, we are going to use the same two properties. In this, some term of x is given, also some number with that is also given. So what we have to do, see, you have to differentiate this fx. So I have written d over dx of fx and also written d over dx in right hand side. Right hand side there are so many terms. So we'll differentiate all the terms individually. We differentiate this differentiation with the second term and so on till 1 we will differentiate. On using the theorem d over dx x raised to power n is equal to n into x raised to power n minus 1. So this is 1 upon 100 as it is, and x raised to power 100 differentiation is 100 into x raised to power 99. Similarly, 1 upon 99 is as it is. Differentiation of x raised to power 99 is 99 into x raised to power 98. Using this theorem. And so on, we will keep on differentiating. Learn it, differentiation of x is 1. Applying the same formula, you will get it as 1. So keep learn it in your mind that differentiation of x is 1. And similarly, differentiation of 1 is 0, or in place of 1, if it is 2, 3, 5 or any number is there, differentiation will be always 0. So use these two things directly. Wherever there is a differentiation of x, need not to apply formula x raised to power n. You keep it in your mind that differentiation of x is 1. And similarly, derivative of any constant number is always 0. If only constant number is there, there is no function of x with this. So derivative of this is 0. So I have written differentiation of x is 1 and derivative of this is 0. So now we are able to find f dash x. Whatever this is coming, this 100 is cancelled out with this 100. Similarly, this 99 is cancelled out with 99, 2 is cancelled out with 2. Now we are left with x raised to power 99, x raised to power 98, so until x from here and 1. You have to find f dash 0. F dash 0. So what to do, in this is also known as f dash x. d over dx of fx is also known as f dash x. Both are one and same thing. D over dx of fx is also known as f dash x. So in this f dash x, you replace x by 0 to get f dash 0. So on replacing x by 0, this term is 0, this is 0, these all terms are 0, only this one is left. So f dash 0 is 1. Now you have to find f dash 1 also. Because in question you want to prove that f dash 1 is equal to 100 times of f dash 0. So I have obtained f dash 0. Now I will obtain f dash 1 using the same formula. So in the same thing, you replace x by 1. On replacing x by 1, it is f dash 1. And right side 1 raised to power 99 plus 1 raised to power 98 till 1 plus 1. So in all these terms, we will have 1. So in totality, these are 100 terms. How 100? From x raised to power 99 to x raised to power 1, these are 99 terms. And 1 is also there. So total, these are 100 terms. And value of all will be equal to 1 only. Because any 1 raised to power anything is 1 only. So it is equal to 100. There are total 100 ones. So on adding this, you will get it is equal to 100. So f dash 1 is equal to 100, whereas f dash 0 is 1. So we can write f dash 1 is equal to 100 into f dash 0. Because f dash 1 is 100 and f dash 0 is equal to 1. So we can write f dash 1 is equal to 100 into f dash 0. Come to the question number 6. fx equal to x raised to power n, a raised to power a into x raised to power n minus 1 and so on it is given. You have to find the derivative of this. So we'll differentiate all these terms separately. We'll write d over dx of this whole expression. Now we'll differentiate this x raised to power n. This constant we will take outside. I have just explained one property. Some constant is there, so you have to take it as outside. Suppose it is d over dx of some constant k into function of x. Now what is constant? What is definition? Anything independent on x. We'll take this outside. In place of k, suppose 5 is given, we'll do the same thing. So in this question, we'll use the same property. So in this, we have taken a outside, derivative of x raised to power n minus 1, a square outside, derivative of x raised to power n minus 2, and finally so on. A n outside, derivative of 1. Use the formula of x raised to power n is n into x raised to power n minus 1. So we'll differentiate this. This is n into x raised to power n minus 1. This is n minus 1 into x raised to power n minus 2, and so on. And finally, derivative of this is 0. I have just explained in the previous question that derivative of a constant is 0, whether it is 1, 2 or anything. So its derivative is 0. So in this way, this question is over. Come to question number 7. For some constant a and b, find the derivative of this. It is x minus a into x minus b, first part. X minus a into x minus b. So I have multiplied it. It will become x square minus a plus b into x plus ab. Okay, I have multiplied this with this. Now we have to differentiate this. So we'll differentiate x square, we'll differentiate a plus b into x and ab, all three terms. So differentiation of x square, a plus b, as I just explained, you take it outside, and derivative of x and derivative of ab. As I just explained, the derivative of x square is 2x, derivative of x is 1. Wherever you get x derivative of x, it will be always 1. And this is a constant, so its derivative is 0. So we will get only 2x minus a plus b. That is the answer. Now come to the second part. Ax square plus b whole square. You just open the bracket, it will be equal to a square x4 plus 2ab x square plus b square. We'll differentiate it. So there are total 3 terms. We'll write the derivative of this. So a square we will take outside. It is a constant and derivative of x4. In this twice a we will take outside and derivative of x square, and third derivative of b square. So over here d over dx of x4 is 4x cube. In this d over dx of x square, using x raised to power n, it will be 2 into x raised to power 2 minus 1, that is 2x only. While calculating derivative directly, you can use the formula. It's very simple. Suppose you want to find the derivative of x7. You take this 7 outside and its power will become 6. Suppose you want to get derivative of x8. So it will be 8x7. Reduce power by 1. So directly we are using it. So like derivative of x4 is 4x cubed, derivative of x square is 2x, and this is a constant. Mind it. So derivative of constant, as I explained you, it is equal to 0. In this way, we'll have the answer of this question also. Okay, now next question is actually fx x minus a upon x minus b. So in this, we'll use the quotient rule. Now, what is quotient rule? The question arises, what is quotient rule? So I will just explain the quotient rule. In quotient rule, you have a function in numerator, function of x, and function of x in denominator. You have to differentiate it. Our formula is, you keep denominator as it is. Find the differentiation of numerator. I am writing it as f dash x minus sign. Now numerator as it is, and derivative of denominator divided by denominator whole square. This is the formula to differentiate quotient. Px divided by qx, fx divided by gx form, means numerator divided by denominator, both are function of x. Then we use this as the formula. The denominator as it is, differentiation of numerator, minus sign is there. Numerator as it is, differentiation of denominator divided by denominator whole square. I will repeat the same formula in the questions. In this question also we'll use the formula because it is given x minus a upon x minus b. So exactly it is numerator divided by denominator form. So you see I will apply the same formula. How the formula is applied, you see. Denominator as it is, and I am writing differentiation of numerator. Minus sign, numerator as it is, differentiation of denominator divided by denominator whole square. Now differentiation of x minus a you have to write. X minus a. So see, differentiation of x first we will do. How we will do differentiation of x minus a? Differentiation of x minus a. So differentiation of x minus differentiation of a. X is 1, that I have explained in many questions, and differentiation of a is 0 because this is constant. So derivative of this is 1. Similarly, differentiation of x minus b will be also 1 because it will be also same. In place of a, it will become b, so there will be no change in differentiation. So derivative of this is also 1. Derivative of this is 1. So I have replaced these by 1. Now you further simplify it to get the answer of this question. Okay, only further simplification is required. So simplify it, you will have the answer of this question. Question number 8 is given. Question number 8, differentiate x raised to power n minus a raised to 1. We will use the same quotient rule. So f dash x is equal to derivative of this thing. So denominator as it is, you see, differentiation of numerator minus numerator as it is, differentiation of denominator divided by denominator whole square. Now you have to find the derivative of x raised to power n minus a raised to power n. So first we will differentiate x raised to power n. This x raised to power n, so its derivative will be n into x raised to power n minus 1, and then differentiation of a raised to power n. You see a is constant, you will take it as constant, so its derivative is 0. Similarly, in this d over dx of x minus a, I explained in previous question, so it will be 1 only because first we will differentiate x, that is 1, and differentiation of a is 0, so it is 1 minus 0, and that would be 1. So in previous question I have explained it how derivative of x minus a is 1, because derivative of x is 1, you learn it. In many questions we will use time and again. Now you just simplify it. So normal simplification is required and you will have your answer. Normal simplification you will get your answer. Similarly, your question number 9 is there, find the derivative of 2x minus 3 by 4. So many questions parts are there, so it is quite simple. You have to find derivative of 2x minus 4. So f dash x. So that will be equal to d over dx of 2x minus 3 by 4. First derivative of 2x, so 2 will take out and differentiation of x, and derivative of 3 by 4. Now differentiation of x is 1 and this is a constant, so differentiation is 0. So it will be 2 only. Similarly, in this question, we'll use the product rule. In previously, I explained you the quotient rule, and now this is the product rule. Now what is product rule? Product is if product of two function is given, d over dx of fx into gx is given, or two functions u and v is given. How to do it? So in this, what we'll do, you keep u as it is and differentiate v plus sign. Now keep v as it is and differentiate u. That's all. This is d over dx of v. A product of two functions is given, we will keep one as it is and we'll differentiate the second one, and then we'll keep second as it is and we'll differentiate first one. So the same formula I will apply in this question also. You just see it is given 5x square plus 3x minus 1. So see it carefully. I am applying product rule. How? This is as it is and derivative of this second function. Plus now this second function as it is and derivative of first function, you see. Product of two functions is given. Now we'll calculate simple derivative. Derivative of x minus 1 will be 1 only, because d over dx of x is 1 and d over dx of 1 is 0. This x minus 1 as it is, now we'll differentiate this. 5x cube. So 5 as it is, differentiation of x cube is 3x square. The derivative of 5x cube. Now in 3x, 3 as it is, differentiation of x is 1. So it will be 3 only, and derivative of this 1 is 0. Now you just further simplify it to get the answer, and you will have the answer. Okay, so you try till this. Remaining questions we will discuss in the next class, and I hope you will get the help from this video. Thank you.